Let's begin by setting up our project first. So I've created an empty Unity project. It's a 2D project and we have our sample scene. So first thing we are going to do is change our settings to Android. So it will just have all the settings set to Android, and it will also import the respective packages. So it will take a couple of seconds, and after that we will uh, go inside project settings and change the text mesh pro warning. So it will take a scripts are compiling and it should be done in around 5 to 10 seconds. It is taking a little bit of time. So setup should be done pretty fast. There should not be any problems. Again, compiling scripts. Why is it taking? We'll wait. So let's wait for it to compile. And the current game we are going to create is the fill game where we have different cells. Some of them are blocked, and we are just going to create a flow or an edge. And the goal is to fill all the empty positions in just one stroke or just one line. So as you can see, it is done. Now let's create a new scene, and we are going to save this scene as gameplay, and we'll delete our sample scene, so we don't need the sample scene. And after that we'll add our scene, and let's go inside player settings. So we'll import the text mesh pro so it doesn't cause any error as it's already imported in packages. So we need to import it here. If we use any text or button, then it is automatically going to import it, but we are going to do it now. And inside the editor naming convention, let's use underscore. And there is no toolchain management, but there will be the package, so we'll set up our packages. So we need the Visual Studio editor. Let's update it. We are going to remove the VS Code editor. So it is updated, and every time the package updates, it is going to reload the assembly. So we don't need the VS Code editor, we don't need the Visual Studio, and the less packages you have, the final build size will be smaller. So the visual scripting takes so much space, so I think it takes around 20 megabytes extra. So if you're just creating a simple game when you build for the Android, it will be 50 MB. But if you remove the visual scripting, which we don't need it, it should be around 30 MB or so. And we are not going to need the test framework and the JetBrains Rider editor, so we are also going to remove that. So some of the script loading, it will take around 20 to 30 seconds. If you have a fast PC, then it may be done in a blink. We also don't need the JetBrains Rider editor, and we'll update our timeline. So these are the packages, and after we are done with our packages, we'll close both of them. And we also don't need the build settings. And for our game, instead of free aspect, let's use the portrait 2160, and we are also going to close the package manager. Now let's bring in our resources. So for our resources, we are going to bring in the resources and the editor folder, which includes the colors and the sprites. And Inside our editor, as you can see, we have this four colors. So let's change our color to our light dark gray. And after that, we are going to create our prefabs and our scripts folder. And finally, there is also going to be our generator folder where we are going to put our level generator scene, and we'll create that scene, create, and where did we add it? So let's save it inside our generator, and we'll save it as generator. And also it is going to need the generator script, and we are going to call it level generator. And also inside our scripts, we are going to have three scripts. The first one is going to be our level script, and next one is going to be our cell script, and the final one is going to be your game manager. So we have created all the assets, all the scripts. Prefabs will create it in the next part. So let's go to the next part. So in the previous part, we created all our prefabs, and not the prefabs, we set up our project. And in this part, we are going to create all the prefabs and our level storing the level, which is just going to be a simple list as we already done in all the previous puzzles. We are not going to do anything complicated, so let's do that. And let's go inside Visual Studio, and let's open our level. So level is going to be a scriptable object, and let's use create asset menu, and our file name is going to be level, and our menu name is also going to be level. And our level is going to have just three parameters: public integer for the row, public integer for the column, and public list of integer for our data. So pretty simple, nothing too complicated. And let's create that level inside our scene. So we'll go inside Unity, and inside our prefabs we are going to create our level. And this one is going to be just a simple 3x3 level. We'll see how we are going to edit it later. And the fifth element, which is going to be the element 4, is going to be 1, which represents the blocked state. And our main camera is going to have again the light gray color. And let's go inside our gameplay scene. Now let's create our prefabs. So we are just going to have two simple prefabs. The first one is going to be our cell, and it is going to have a sprite, and the sprite is going to be our circle, and the color by default will make it black. And let's attach the cell script, and the scaling, it's going to be 0.6, and we are going to save it as a prefab. And black, let's make it yellow color. And after our cell, we are going to have our edge, which is just going to have a sprite renderer, but the sprite is going to be our pixel, and we'll make it sliced. And the size, it's going to be 0.16 by 1, and we'll have it ordering layer a little bit higher, and again its color is going to be yellow. And we'll also save it as a prefab. So we have our cell and the edge, and now what we need to do is how our cell is going to react. So at the start, and when we change the states, so we'll need to code up our cell, and let's see how we are going to do that. So let's use hide and inspector. It's going to have two states. The first one is going to be block, and hide and inspector public pool for our field. So, and we are going to have serialized field, private color, and block color, serialized field, private color, empty color, and serialized field, private color, filled color. So there are going to be the three colors, and after that we are going to have a sprite renderer, and we'll just call it cell renderer. And first we are going to have the initialization function where we are going to pass the value where 0 denotes empty and 1 denotes block. So our block is going to be if our fill is equals to 1, and our field is going to be equal to block, and our cell renderer dot color is going to be if we are block then block color, else empty color. And after that we are going to have two functions. First one is going to be add. So whenever we add, our field is going to be true, and our cell renderer dot color is going to be equal to our field color. And after that remove, our field is going to be false, and our cell render dot color is going to be empty color. And finally there's going to be one more, which is going to be change state, and this function we are going to use inside our editor where our blocked is not blocked is going to be not blocked, field is going to be equal to block, and finally our cell render dot color is going to be if it is blocked, then we are going to use the blocked color as empty color. So these are going to be our prefabs, and there is nothing too much complicated here. And we are going to use our prefabs to spawn our grid, which we have stored the data inside our level, and we'll see how we are going to spawn in the next part. So in the previous part we created our prefabs and the cell script. Now we will see how we are going to spawn it inside our grid. So let's go inside Visual Studio, and let's delete everything. Let's add our game manager instance inside our awake. We'll set the instance to this, and let's create a serialized field level and serialized field private cell prefab and serialized field private transform, and final one is going to be our edge prefab. And after that we are going to have a private pool of has game finished, private cell array to store all of our cells, and we'll just call it cells, private list of vector2 integers, and this is going to be our field points, and private list of transform, and this is going to be our edges, and finally private vector 2 integer start pose and our end pose. And finally we are going to have a private list of vector 2 integers, and we'll call it directions, and it's going to be new list of vector 2 integers, and we'll add our up, down, left, and right. And inside our awake we are going to set the has game finish to false. Build points is going to be new list. Self is going to be a new self, and we are going to pass our level dot row and our level dot column. And also our edges is going to be new list, and we are going to spawn our level. Let's create our spawn level function, and inside our spawn level, let's first set up the camera main dot transform dot position. Compose.x is going to be equal to level dot column multiplied by 0.5. Compose.y is going to be equal to level dot row multiplied by 0.5. And finally, we'll set the camera dot main dot transform dot position to compose, and camera dot main dot orthographic size is going to be equal to math.max of level dot row and level dot column, and we'll add 2f. And finally, we are going to spawn our cells, and our cells are cells of I comma j is going to be equal to instantiate, and we are going to instantiate our cell prefab cells of I comma j dot init, and we are going to pass level dot data I multiplied by level dot column plus j. And after that, we also need to set its position. So transform dot position is going to be new vector 3, and we'll pass j plus 0.5, I plus 0.5, comma 0. And that should do the trick. Yeah, we don't need to do anything, but we need to create one more function. So private void check win, and inside our check win, we are just going to go through the loop level dot call, and if not cells of ij dot filled, then we are going to return, else we are going to start the coroutine. Our game finished, and before that we'll set has game finished to true, and we need to create our coroutine. So private enumerator game finished, and here return new, wait for seconds, we'll wait for 2 seconds, and after that we'll use unity engine dot scene management dot scene manager dot load scene, and we are going to load the 0th scene. So that should be it for the start. Now we can spawn our cells, and our camera position will perfectly align. So inside our gameplay, we need to create our game manager and add our game manager component, our level, the cell, and also our edge. And our cell needs to have the colors, so our block is going to be black, empty is going to be white, and our filled is going to be yellow. And our sprite render is also going to be attached. Now let's hit play, and as you can see, the grid is created. So it is a pretty simple grid. We are not done anything complicated, and we are going to do the editing part later. So Next, we'll see how we are going to pass our input. So we'll do that in the next part. So after we have spawned our cell, we need to get the input and change the cell state and also create the edges. So let's do the coding part. And first we are going to create a couple of helper functions. So the first one is going to be private bool and is valid, and we are going to pass our vector to integer of position, and we are going to return pose.x is greater than equal to 0 and pose.y greater than equal to 0, and x is going to denote the row, so pose.x is going to be less than level.row, and finally pose.y is going to be less than level.call. And one more, which is going to is neighbor. So if our starting and ending points are neighbor, then it is going to return true or false. So we are going to return is valid and start pose, and is valid and pose both of should be valid, and our directions dot contains our start pose minus end pose. So if all three of them are true, then it is going to be a neighbor. Now let's go inside our update, and the first thing we are going to check if our game has finished, then we are going to return, else not else. If we are not returned, then we'll check if we have pressed input dot get mouse button down of 0. Then let's first get our mouse position, which should be camera dot main dot screen toward point of input dot mouse position. Then we'll set the start position to be a new vector to int of mathf dot floor to int, and we'll pass the mouse pose dot y because that's going to be the row, and again mathf dot floor to int of mouse pose dot x, and also we'll set our end position to be equal to start so it doesn't create errors, else if input dot get mouse button of 0. So instead of down we have pressed, then again we are going to do the same thing, but instead of start we'll set the end, and first we'll check if is not neighbor, then we are going to return. But if both of them are neighbors, that means we need to draw the edge. Then if we have to add an empty, then we'll add the empty, and we'll need to create the function else if we need to add to the end, then we are going to add to the end, else if add to start, then we are going to add to start, else if remove from end, then we are going to remove from end, and finally remove from start, then we are going to remove from start. So these are going to be the conditions we'll need to create that, and finally everything is finished. We'll set the start pose to be equal to our end pose. That is already done. Our start position is going to be our end position, And before that, we are going to check the winning condition, and also we are going to remove the empty. So if there are any empty, then we are going to remove it. Now let's create the remove empty. So the remove empty is going to work when we just have we have removed like the last cell, not the last cell, the last edge, but it is only going to remove the one of the 2 points, not both of the points. So if filled points dot count is not equal to 1, then we are going to return. But if it is equal to 1, then cells at fill points of 0 dot x dot y dot remove, and we are going to remove at 0. So it is going to remove the start. Now let's see what we have to do inside our add empty. So how our condition is going to be checked? So at the end we are going to return true, but when we are going to return false. So if our else at start pose dot x start pose dot y dot filled, then we are going to return false. Similarly, if our cells at and pose dot x pose dot y, if it is filled, then we are going to return false. And if our edges dot count is greater than 0, then also we are going to return false. So let's put this condition at the start. And so what we are going to do when we are going to add an empty. So we need to add first the starting position and the ending position, and cells at start pose dot x y dot add. Similarly, cells at and pose dot x y dot add. And let's create an edge is going to be instantiate, and we are going to instantiate our edge prefab. And after that, we need to set its position. So edge dot transform dot position is going to be new vector 3, and the x coordinate is going to be start pose dot y multiplied by 0.5 plus 0.5 plus end pose dot y multiplied by 0.5. Similarly, start pose dot x multiplied by 0.5 plus 0.5 plus end pose dot x multiplied by 0.5, and finally 0f. And we need to check if it is horizontal, so bool horizontal. So it is vertical if is end pose dot y minus start pose dot y is less than 0, or end pose dot y minus start pose dot y is less than 0, I mean greater than 0. So if both of them is true, then it is going to return true. Now let's create all the functions, and if there were not any errors, then we should be able to create our start. And let's see. So edge dot transform dot Euler angles is going to be new vector 3, 0 0. If it is horizontal, then we are going to rotate it 90 degrees, else we are not going to rotate. So if it is horizontal, then the y coordinate is going to change, which is going to be the column, and the x coordinate is going to remain same. So it should be greater than 1 or -1. So it would be triggered. But if it is vertical, then it will be 0, and both of the conditions will be false. Now, if we didn't create any errors, we should be able to get our edge. And let's see. So it created an edge, and also it also created a horizontal edge. And the method of equation is not implemented. Okay, so it is showing the errors which we are not implemented. And instead of remove from start, we are going to return true, and return true, and return true, return true. And let's see. So remove from start, add empty. So how we are going to have the conditions for add to end? Mm, mm, mm. So first thing we need to check if filled points dot count is less than 2, and then we are going to return false. We don't need to do that there, and let's create a vector to end position is going to be filled points of filled points dot count -1, which should be the head to end. Okay, -1. So last cell is going to be cells of pos.x and pos.y, and if our cells at start pos.x comma start pos.y is not equal to our last cell, then we are going to return false. And if our cells at our endPos.x comma endPos.y dot filled, then also we are going to return false. It should be empty. And what we are going to do when we are adding to the end, hmm, hmm, hmm. So we are going to add our end position to our filled points, and after that our endPos.x and endPos.y is going to be added, and we need to create our edge. So edge is going to be instantiate, and everything else is going to be similar. Now, mm, when we are going to add to the start, instead of add, we are going to insert at 0. And we forgot to add the edge, so edges dot add edge. So after creating the edge, add to end edges dot add edge, and also here edges dot add edge. And when we are going to add to the start, edges dot insert, and we are going to insert at the 0 over edge. So we can add to the start and add to the end. and our add to the end condition is going to be add to the start condition is going to be pretty similar. So let's copy paste it here. And hmm, hmm. So add to start, if the filled points are less, then we are going to return. But uh, the last cell is going to be our first cell, which should be at the 0. And if the starting does not match, then we are going to return. And also our end post should be filled, so it is pretty similar. Where did we get an error? Okay, here. Now there are not any errors. So as you can see, it was pretty similar. Now we should be able to create all the edges and the game should be able to finish. So let's go inside Unity and suppose if we are not done any errors, then our game should have finished. And we need to have the last function to remove from both of the sides. So that's only going to be remaining. So let's create add to end, add to start, remove the empty, remove the end. Let's realign everything. One space. And put it here. One space. One space. So for removing, the two cells should match. And let's see, remove and so remove from end. If fill points dot count is less than 2, return false. And vector to integer of position add to end. So last cell starting position does not match the last cell, then we are going to return false. And we are going to copy this again. Instead of getting filled points count minus 2 last cell, we are going to check the end position. So our end position should be the second last cell, and if it does not match, then we are going to return false. Similarly, we are going to copy this whole code here, and instead of getting the 0, we will get the 0th and first. I mean, getting the last and second last, will get the 0th and first. And now we need to add the remove end function. So transform remove edge is going to be equal to edges at edges dot count minus 1 and edges dot remove at, and we are going to destroy our remove edge dot game object and build points dot remove at, and we are going to remove the fill points dot count minus 1 and the cells at start pos dot x dot y dot remove. And similarly, let's copy this, and again it is going to remove from the start, but instead of the last edge, we are going to remove the 0th edge. Hmm. 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 And remove from start, remove from end. Okay, so the conditions are matching, and if we have not done any errors, then we should be able to undo everything. And let's see, we can remove it here. And so our game should be finished, and that is the basic logic for our game. And didn't take much time, so there was nothing complicated, and we already created like seven such games, so we can always find the shortest solution and will not run into any obstacles. So that was just the core logic for the game. And in the next part we'll see how we are going to edit our levels. So it is pretty much similarly going to be our game manager, but we are just going to add one more condition where we can create our blocked cells, and we are going to save that inside our scriptable object. So that's it for this part. So in the previous part, we created our core gameplay loop, which should set us up all the levels, and the game is going to finish there. And now we are going to set up our generator, which is going to be a level generator. And let's see how we are going to do it. So the code is going to be pretty similar to our game manager. So we are going to copy the whole script for our game manager, and we'll add it to our level generator. And we are not going to need the check when and the game finished. So we'll remove that. And check when is going to be removed. The game finish, we don't need to check that. And we are also not going to need the instance, so we'll remove our public static game manager instance. We are going to have a private integer for the row and serialized field private integer for the call. And we are going to remove the hash game finish, and before creating our list, so our list is always going to match our row and the column, so we don't need to get it from there. We need to create our level, so let's create the function create level. It's going to be private void create level, and if our level dot row is equals to row, and our level dot column is equals to column, then we are going to return, as our level dot row is going to be row, level dot column is going to be equal to column, and our level dot data is going to be new list. And for int I is equals to 0, I less than row, for int j is equals to 0, j less than column, level dot data dot add, we are going to add 0. And after we have added 0, editor utility dot set dirty, we need to save our level, and that should be it for the starting condition. And we should be able to create a level if there are not any errors. So let's go inside Unity and let's create a 3 cross 3 level, and we'll add our level, our cell, and also our edge, and let's hit play. So we should be able to see a 3 cross 3 level, and the game is finished, but this is our generator, so we are just checking for just the editing part. Now what we need to have is whenever we right click, we should be able to update our cells. So as you can see, currently the cells are not getting updated. So we need to attach one more function on right click. So let's do that. So let's go inside Visual Studio, and before, if input dot get mouse button down of 0, if input dot get mouse button down of 1, which should be equal to a right mouse button, then we will get our mouse position and the starting position. And after getting that, if is a invalid position, then we are going to return, and we are going to check if it is blocked. Cells at start pose dot x comma start pose dot y dot block, and bool again filled is going to be cells at start pose dot x comma start pose dot y dot filled. And if we are not blocked and it is filled, then we are going to return as we are. Yeah, so we are going to change the state. So start pose dot x comma start pose dot y dot change state, and we also need to update level dot data for our start pose dot x multiplied by column plus start pose dot y, and if it is blocked, then it is going to be 1, else it is going to be 0. But we need to change it, so it is going to be switched. And finally, we also need to save it, so editor utility dot set dirty, and we are going to pass our level, and that should be it. Nothing too complicated, and after that we should be able to edit our level. So let's hit play and let's see if we are able to edit our level. So both of them are black, and this is our level, and it should be saved, and we should also be able to play. So let's go inside our gameplay scene and let's see if we are able to play. Then the game should be finished and it is saved and the game restarted. Let's go inside our generator. We'll create a 4x4 level and let's see if it gives us a new one. So mm, and again we'll check if it is saved, then we should be able to play. So this is our fill game. Everything was pretty much simple. We didn't get any complicated errors. And that should be it for this game. If you did like the video, do like and subscribe to the channel. And if you bought it on Udemy, thank you for buying. And we'll see you in the next game.